Hi, my name is Fraser, and welcome to Graphic Card Repairs. So today we have a Palit RTX 3080, and I'll give you a background of this card. This card was bought by a user, and he said that when he installed the card on his computer, there was no display, and he tried fiddling around with his computer, and that's when the computer stopped booting. So whenever he pressed the power button on the computer, and the computer wouldn't start. So and he got it to me. So I assume there's a short circuit, and also we have a problem with the display as well. So we might have to look at two different angles here. One is the short circuit, and one is the display problem. So to start off, let's take some measurements and check what exactly is the issue here. Now, just to give you a heads up, the seal is still intact. So this card hasn't been opened before, which is a good sign. Let's start with the resistance. 12 volts PCIe. And we don't have a short. Let's look at 3.3 volts. And we don't have a short. Let's look at the first 8 pin. Oh, sorry. And we have about 1 ohm. Let's look at the second 8 pin. And we don't have a short. So we have a short on this 8 pin. This one is fine. So I'll open this card up, and we'll continue from there. Okay, so the cooler has been taken off, and I don't see any visible damage on the card. So I'll switch over to the microscope. There you go. Let's take a look. Okay, so there's nothing visible on the top side. Let's take a look at the bottom side. Okay, so I don't see any kind of visible marks or anything like that, which may indicate that there's any chip has been damaged, but it could be that it's not very prominent. We might have to inject some voltage and check which one is the faulty one. But as of now, everything looks to be okay. So our faulty pin is this one. Let's take some readings, and then we shall, proceed from there. Okay, so on this particular 8 pin, let's switch the multimeter. So it's almost a 0 ohm short on this pin. This one is fine. So there are two shunt resistors, one on this side, one on this side, and there's one here. And this one is short as well. So let's take a look at 1.8. We don't have a short here. PEX. Specs is 3.7, a little bit on a lower side, but it's okay. So I will pause the video here, connect my jumper wire, and we'll continue from there. Okay, so I have connected my wire here on this particular inductor. So I'm just ensuring that this wire is straight up and not touching anything else. I will inject voltage, so I'll switch over to the overhead camera and move this out of the way. So I've connected my power supply there, and I will inject some voltage. Okay, so I've connected the wire. Now I will inject voltage. I'm injecting 0.8 volts at 4.5 amps. And it's drawing 1.6 amps, 1.7 and rising. Can I check if anything is lighting up? But I don't see anything lighting up. Let me turn this off. I want to check if the voltage is bleeding over to the other side. So I'm going to just check for the voltage and check if my voltage is coming onto the core. Yes. So the short Okay, so you can see the voltage is bleeding over to the core. So the short is somewhere on one of these, MOSFETs. So 0.8 volts is bleeding over to the core. So I cannot inject a higher voltage. Let me check on this side. So whatever I'm going to inject, it's going to shoot over to the core, instantly killing the core. So which is not a good thing. So I cannot increase the voltage. So you can see the cores that are connected. That's 1, 2, 3, and I also have one here, 4 and 5. So these 5 MOSFETs are connected to this coil. I'll turn the thing off and I'll just probe around and check where my short is coming from. Okay, so I would like to give you an update. I was just probing around and I found something, something that can be a clue, and that might be the case. So if you can see these 3 MOSFETs that you see on your screen, that's 1, 2, and 3. These 3 MOSFETs are connected to the shunt resistor on that 8 pin. So when I was measuring, which one connects directly, and when I was probing around, when I touched this particular pin, it just broke off. It may be something irrelevant, but I feel that there might be some relevance there. Now, the others, if you just take a look visually, the others look, they look okay, but this one looks a little bit more messier than the others. So when I touch here, this solder joint just broke off. It should not. Whereas the rest of it are okay. It might be irrelevant, but what I feel is this might be the faulty MOSFET. Now, injecting voltage is not helping because I cannot inject anything higher, because the 8 pin is directly, the 12 volts is directly shorted to the core. I inject any higher voltage and the core will die. So we don't have the the leverage to go ahead and inject higher voltage to find out where. So we have to do it a bit manually. And I feel that this might be the MOSFET that is faulty. So I will, the only way that we have now is just to do guesswork and continue from there. So I will lift this MOSFET out and see if our short goes. So I'll just pause the video, prepare this card for lifting this MOSFET and continue from there. Okay, so the board is nice and warm. Let's proceed to remove the chip. Okay, so it looks like this thing is fused at the bottom. In the process, there are some capacitors that have also been damaged. I may have to replace those, but this thing is fused at the bottom. So I will go ahead and remove these capacitors before I proceed any further. Okay, so what I've done is I've removed the capacitors from here, all these places, so that I can get this chip out. Looks like this chip is fused, and maybe we have found our source of the problem, and we pinpointed exactly to the problem, maybe. But the exact thing we will know once we get this thing out. So I'll just wait for the board to heat up again. I'm going to hit the board up nicely. And once the board hits up, then I will go ahead and remove this chip. So there is one resistor that's just been knocked off a bit over here. I'll fix that up once once the board is nice and warm. So I'll just pause the video again, and we'll come back once we get this nice up and ready. Okay, so I have removed the MOSFET. I've tried to keep the bottom plate intact, and we do have the bottom plate intact. Okay, so let me switch you over to the overhead camera, and we'll measure the resistance and see if our short is gone. Okay, let's measure the resistance on that particular inductor. And our short is gone. So you can see now that we no longer have a short. And it's kilo ohms and rising. So our short is gone, but we have another problem, which is first we'll have to replace this capacitors, and then I will test. And so there are 4 capacitors that I had to remove. It's just that they were overheated and they died. They are useless. So they popped because the proximity it's too close. They are too close to this MOSFET, and there's no much room to work on. So I will have to replace those, and I will go ahead and Once that's done, I will put this on the bench and check if we can go ahead and boot this card. Run some memory tests and continue from there. So if everything works well, then I will replace this MOSFET. The card should still boot without this MOSFET here. Okay, so the capacitors have been replaced, and these are the new capacitors that's been installed. They have been installed from a donor board. They are the same values as the other ones. Okay, let's take a look at the back, at the joints. These are the joints, nice and shiny, and which is good to go. Okay, so everything looks okay. What I will do now is I will run, before I replace this one, let's check under, let's switch my camera. Okay, so let's see if our short is gone. We're going to measure the resistance again. Let me connect this here. And if I measure on the 8-volt, 8-pin inductor, and we can test it. Okay, let's test it. And you can see our short is gone. So it's kiloohm and rising. Let me move this a bit. So you can see it's kiloohm and rising. So our short is gone. It's in the mega ohm now, which is a good sign. Before I replace this MOSFET, I will run maths and see what kind of an error I get. If this chip is still alive, then I will proceed and replace this MOSFET. If this chip is dead, then probably there is no point replacing or working further on this particular card. The cause is that 12 volts has shorted directly. It was shorting directly into the chip, and that was the dangerous part. Okay, so I'll quickly pause the video, switch you over to my bench, and that's the test bench, and show you visuals from there. Okay, so I just want to give you a heads up as to what I did. Before I put this on the bench, I was, I connected it to my power supply to see if the voltages were okay. And there was another MOSFET that died. I will show it to you under the microscope. Okay. So you can take a look over here. Okay. Can you see the MOSFET here? It has popped open. So this is the second MOSFET that died. And I will have to replace this MOSFET as well. Okay, so let's prepare the board and remove this MOSFET. Okay, so the board is hot. Let's remove the chip now. Okay, so the board has cooled down. Both the chips have been removed, one here, one here. Let's take a reading and check if our short is gone. Checking on the shorted line. And we don't have a short. You can see the resistance that's rising beautifully. Let's take a look on the other side. And it's the same. So our short is gone. I'll test the voltage. Okay, so I have connected the power supply. Let's take a look at the power draw. And it's 2.6. Okay. let's measure the readings. Let's check the 12 volts inductor, and we have 12 volts. The other 8 pin, we have 12 volts. Let's take a look at 5 volts, and we have 5 volts. Let's check 1.8. We have 1.8. Let's check PEX, and we have PEX. Let's check core. We have core, and we have memory. So we have all the voltages that are required. I will put this card on the bench and check if we get a picture now. So if we get a picture, then I'll replace the MOSFETs that have been shorted. Okay, so the card has been put on the bench. I will boot the card now. It is detected, and we have a picture. So the card is booted, and we have a picture. So it's a fix. So I will put this card back onto my workbench and replace the MOSFETs that are missing. So I'll quickly pause the video and continue from there. Okay, so I have put the card on the bench, and we will just prep this card now. Okay, so one chip is installed. Let's install the other one as well. Okay, so both the chips have been replaced. This one as well as the one here. Okay, so the capacitor that was knocked off, that has also been replaced. So I'll just wait for the board to cool down, and then I will test this card. Okay, so the board has cooled down. Let's take the resistance measurements. Okay, the one which was shorted earlier, and we don't have a short. The second 12 volts, we don't have a short. Okay, so let's put this card on the bench and the test bench and see if the card boots. Okay, so the card has been installed on the bench. Let's boot the card now. And we have a picture. So this is a working card. I will switch it off, put the cooler back again, and we'll start. We'll stress test the card after that. Okay, so the cooler has been installed. I'll boot the card now. We have a picture. I will boot into Windows. Let's open Device Manager. Waiting for the drivers to load. Once the drivers load, we'll run the test. Okay, drivers have loaded. Let's take a look at the display, and I don't have any memory errors. So I don't think there was any memory errors here from the start. I think the customer was saying that there was no display. It could be that there was a short and customer tried booting it again and again and may have blown the other MOSFET too. That could be a possibility because I don't see any memory errors. So let's run a couple of stress tests and see if the card is stable. So to start, I will run 3 tests together. Okay, so if I'm looking at the sensors, I see all the sensors working. The power draw is normal. Everything is perfect. Let's run the test. Okay, I don't see any artifacts. The temperature is rising smoothly. The hotspot and the memory temperature is almost the same, which is a good thing. The variation between the GPU and the hotspot is just about 10 degrees, which is excellent. There are very few cards that I see with that kind of a variation. Most of them I see it about 13 or 14 or 15 degrees. But this temperature is fine, absolutely fine. There's nothing wrong. So I will keep this card running for about another hour or so and see if the card is stable. As of now, this card is fixed. If you like this video, please hit the like button and subscribe for more content like this. So also do make sure that you comment if there is anything that you like, anything that you did not like. Probably you would want me to change the way I make my videos or present my videos. Anything that you would like to see different, don't forget to comment in the comment section. I make sure that I read all the comments and respond to them as well. So thank you for watching. You have a good day. Bye for now. Cheers.